Hello everyone, welcome to the second part of this series. So we are uh, learning the basics of ROS using ROS Development Studio. So in our previous video we covered the first five topics, up to this understanding ROS nodes, and today we will see um, how topic works. We'll learn about topics and how do they work. Just a recap of the last session. The nodes are the executable programs in ROS that can communicate with other nodes using topics or through services. So today we'll see how the ROS topic works. For that we'll run ROS course. So this is ROS Development Studio, and from the tools we start the shell. So we already have a shell here. So in this one we'll run ROS core. It is the main kind of server that maintains all the nodes, their communication and things like that. So, and you can run only one ROS core. So if your ROS core is already running and if you start another one, it will give an error. For example, if I start another shell and I say I run the ROS core again, it will give an error saying that ROS core master is already running. So you cannot have two ROS cores. Alright, so then we'll run another node called turtle sim. So ROS run turtle sim node. We run it. So graphical tools, so this is we use to see the desktop. Okay, so we'll press Ctrl C here so that we'll start it again. So you can see a turtle in the middle of the window, and now you start another terminal, and in this terminal we want to run ROS run turtle sim turtle teleop key. So this program will use to move the robot around. So now if I use the arrow key upward, it goes straight, and then right key to turn right, back, forward, again right, forward, and so on. So using this turtle teleop key node, we can control the motion of the this simulated robot. Okay, so to see what what is happening underneath this one, we'll need something called RQT graphs. If we run RQT graph, I'm assuming that RQT graph is already installed. If not, then probably we'll have to run this command to install the RQT components. Let's see what does it say. So it's not saying something. Okay, it has already executed, and you can see that so what you see is now Teleo of Tuttle is a node, and Tuttle Sim is also a node. These are two independent programs, and Teleop is communicating with Tuttle Sim using this topic Tuttle1 CMD well. So this is giving the motion command to Tuttle Sim. So this is what it's saying. So uh, so command velocity CMD well is our topic, while these two are two nodes. Now to okay, we'll start another shell. So if I do ROS topic minus h, it shows all the uh, help commands available with ROS topic. So that means we can see the bandwidth, we can see delay, echo, find, the frequency of publishing rate of topic, info, list, and all those things. So we'll try this ROS topic list. It will show you all the topics that is available. So you can see ROS out and ROS out AGG. These two are probably associated with the ROS core itself. And then we have this Turtle1 CMD well, color sensor, and pose other topics. So you can run ROS topic echo to see one of them, probably Turtle1 CMD well. So it will show you the output of that one. So currently it's not showing any output because the robot is not moving. So if we go back to the earlier one, not this one, not this one either, we are going to the Turtlebot Teleop one because we want to move. See, and as you move it with the arrow, you can see the output is coming, right? So in the beginning it will not show because no command is being passed, so no data is there in that topic. Okay. All right. So at that time, if you see if I refresh this RQT graph, this refresh button here, you can see now there is another topic called ROS topic this, and it is reading from the CMD file topic, but you can say that's another node. Sorry, the ROS topic, this particular command runs another node which is subscribing to the CMD well. That it means it is reading the data from this particular topic. Okay. Yeah. So all right, so we will stop this, and if we do ROS topic list minus v, if we give the verbose option, so you can see something like these are published topics. You have more information compared to the last one, and these are subscribed topics, and CMD well is of type. It is also telling that what kind of messages are being published or subscribed, and you see they have all one subscriber because Turtle Sim is running. But if I run this topic echo and then start another shell, and then say ROS topic list minus v, you can see there are two subscribers now to the CMD well. Because if you refresh it, you see this topic is this a node is subscribing to this one, and turtle sim is anyway another node that's subscribing to it. Therefore there are two subscribers. Similarly, but there are one publisher for the CMD well. So CMD well is also used for publishing as well as subscribing. Okay, now we'll see the ROS messages. So the topics use ROS messages to communicate. So for example, turtle CMD well is a topic and uses a message of this type. So geometry message at twist. So now if I ROS topic type and turtle one CMD well, so I can see the type of messages being used by this particular topic. Alright, so it is of type geometry message and twist. Okay, and if I see ROS message show turtle one CMD well, sorry, ROS message show is used for seeing the messages, not the topics. So if I want to see geometry messages dot twist, it shows that it has three linear quantities and three angular quantities. That means it gives you the position and orientation of the robot. Okay, and so another command is ROS topic publish -1 stands for one time. You just one time give a command. ROS topic publish is used, this command is used to publish a data to a particular topic. For example, we'll give turtle one CMD well. Now we want to give our own command rather than taking from the teleop command. So this one, and then we specify the message type. So the message type we want to send is twist, and then within the quotes we provide the data. So the double is a double line, double dash says that key these are not an option, these are the values. So we give 2 0.0 0.0, then 0.01 0.0 and 1.8. So if you run this, you can see the values. So the CMD value in this ROS topic echo command changes to these values. This is the value we gave to the CMD. And if we see our desktop, and if we minimize this, you see the it has hit the wall. I think it has stopped because it is a one-time command. Okay, fine. but if I give it minus R1, it means that I'm publishing at a rate of 1 hertz, the same command. That means I'm giving it continuously. If I give this and then I check my, and you see it is constantly publishing and the robot is moving constantly, and echo is showing continuous stream of data. Okay, this I will stop. Okay, all right. So we understand this one. -1 stands for only publishing one time, and then we mention the message type. Double dash tells that this is not an option which is going to follow, it is just the values. And this message twist has 6 elements that we saw: position as well the orientation, and it gives that one. That means angular as well as the linear velocity. Basically it gives you the velocity commands that we are giving, linear velocity and the angular velocity. Okay, and if we are to see the RQT graph here, and if we refresh the RQT graph, so Turtlebot teleop is already giving the command. Another topic is this one, it is also publishing to turtle sim. So, and if we run the echo command as well, if we run the echo command as well, that means we are reading it as well. Not only we are publishing it, we are also reading it, which is getting updated. And now if we go here and then refresh the node graph, so you can see there are 2 topics now. One is subscribing to it. You see this topic is subscribing to the CMD well. Other topic is publishing it. Alright, and in teleop we know that it is also publishing, and turtlesim is subscribing to CMD well. So RQT graph is a very useful tool to see the relationship between different nodes and see what kind of topics are being used by them for the communication. Okay, so ROS topic HZ is used to see the rate at which data is published. So for example, we want to see, I want to stop this, ROS topic Arch Turtlebot pose. So I want to see at what rate the pose is getting published. So it is saying that key it is published at the 62 hertz, around 62 hertz. Okay, so it is publishing at a 60 hertz, that we saw that. Another one is called Arcadia Plot. So here you can plot the variables. For example, if I run RQT plot, let me stop the RQT graph now, probably will not need it anymore, so you can stop it, it will save some. Probably this one. No, this is different, maybe this one. Okay, we can stop this. Arrow also, and teleop also we do not need. RQT graph is something we'll stop. Okay. Now if we use RQT plot, suppose slash x and I enter, it shows the, you can continuously plot the x value. Similarly you can plot y together, so then xy is getting plotted. So it is possible to see the graphs and plots live when the robot is moving. So so we'll stop this because it is taking a lot of CPU power. You see, it is taking a CPU power. So what we'll do is we'll stop this Arcadia plot. Alright, so to summarize, we saw how you can gather information about topics using ROS topic command. Alright, so basically we saw command like ROS topic echo, ROS topic list. It lists all the topics that is available. Then you can use pub command to publish data to these topics, and you can see ROS topic type. That means you want to see what kind of message types are used by topics. So just to give a overview, ROS nodes are the executable programs, and they communicate with each other by using ROS topics. ROS topics use messages to communicate with each other. And so now we'll go to the next topic called services and parameters. So so we mentioned that the nodes communicate with each other using either topics or using services. So services allow nodes to send a request and receive a response. That means rather than synchronously or asynchronously sending the data, you can it is more like asking for a service and getting served. All right, and there is a handshake will happen in this kind of communication. So services allow you to handshake, okay, which is not there with the ROS topic. ROS topic is like you just publish some data and people can access it without any handshake. Okay, but here the handshake will happen. That means you will make a request and then you will receive a response. So if we see what kind of ROS service are there, so ROS service has these commands: ROS service list, call, type, find, and URI. So if I do ROS service list, it shows you all these services are available: clear, kill, get loggers, set loggers. I'm sure these two are associated with ROS core. These are associated with the total sim that we are running. Then there is something called spawn. Okay, so these services are available. Okay, so and if you want to see what type they are, ROS service type, let's say clear, I want to see what is of type. It is of type standard services empty. It is of one type anyway. The service is empty, that means the service call takes no arguments. So that means it sends no data when making the request and receives no data when receiving a response. So that is the meaning of empty. There's no input and there's no output. It does the moment you call, it does something. So in order to call this service, we use this call command. So if I say ROS service call clear, So let's see what happens. So it's clear, but it is rotating. So what we will do, let's stop this continuously publishing command. So let's stop this. Okay, and now call raw service clear. If we do this and see the desktop, you'll see that the environment, the background is completely clear. There are no trajectories anymore. Okay, and with the now with ROS service, we'll see what is the spawn is another service that's available. So ROS service type, if you want to see the type of service that is available, it says it is of type spawn. Probably you want to see some more information. So what we'll do, we'll pass this ROS srv show. That means we want to see also what is there. So it says that it has two parts, separated by this line. The first part is the location and the orientation, and the second part is the name. So if I call the service call spawn, then I'll have to provide the data. So you'll have to give input data. So I have to give 2, orientation is 0, okay, 0.2, and then we don't give any name. So it shows that it will take the top one is the input, and the second is a response you get probably. Okay, anyway, so if I do this and then see you see there is a second turtle is spawned here. So it launches another robot at this location. Okay, this is what this spawn does. And since we didn't give any name, it returns a name called turtle2. So let's study this once again. So if you see ROS service show, then it shows this, the top one above this broken line is the input that you give, and this is the response you get. That means you make a request using these values and you get a response of this time. So it gives you the turtle2 as a name. Remember, to see the messages we use ROS message show, but to see the services you see ROS service show. This is what it does. Now there is another tool called ROS param. It allows you to store and manipulate data on ROS parameter servers. It can store all kinds of integer, floats, boolean, dictionaries, list. It can store. It uses a YML markup language for syntax, and you can store it as a file. You can load them, save them. Those things you can do. So it has following commands: ROS param get to get the parameter, set for setting the parameter, load from a file, dump into means write into a file. You can delete parameters, you can list the parameters. for example, if I want to see ROS param list, it shows me all these parameters are there. And further, if I want to see what are these values of ROS param get, I want to see what is the background R color, the red color, what is the value of this. It says 69. I can use ROS param set background R and then say I say 255, let's say. If I go to the desktop and then I'll have to do the clear command and ROS call ROS service call clear. If I do this clear, you see the background has become red, more reddish, so that's how you can change this parameter using the ROS param command. If you want to see the entire parameter server, then we'll use ROS param get. It will show you all the parameters are available with the server. So it says, you see BGR, so we recently changed the rate to 255. Distro, it contains the ROS core address, okay, and some ID is there, okay, fine. It contains all the parameters, and you can use the dump to write the files into a file. For example, if I say ROS param dump params.yml, so it creates a file called yml. So if I edit it, let's say vim params.yml, so all the files, all the parameter that we saw has been written to this particular file. You can also load it, ROS param load params.yml, and you can give a different name called copy. That means you are loading it as a different server, parameter server altogether. So if now ROS param list, if I do, you see these are the original parameters that we had. Now it created a different server called with copy, these are all copies there. So if I want to ROS param get copy background G, so you can get it. Alright, this is how we can load and change the parameters. We saw ROS service commands to see what kind of services are available, and you can use these commands like list, call, type, find to access all the services, to know about them, get information about the services. And then we saw the ROS param list. It allows you to view the parameters that is available with the parameter server. You can change the values, things like that. So today we'll stop at this point, and then we'll continue again next time with other sets of tutorials. Thank you very much for joining this session.